So as we move to the completion of our unit in understanding algebraic expressions, things that look like 2 plus x, where we've been figuring out what would 2 plus x be if x equaled 3. In this case, plug 3 in for x, and 2 plus x would be 5. This is evaluating an expression. We've already done a fair amount of that. But what if we wanted a way to be able to describe or deal with all the possible outcomes? So if x equals 3, then 2 plus x equals 5. But if x equals 6, then 2 plus x equals 6 plus 2 is 8. But if x equaled negative 2, then 2 plus the opposite of 2 equals 0. But already this is kind of annoying, isn't it? Well, one way to deal with this is to set up an equation that says, well, let y, right? So x gets to be all the possible values that we can put into the expression, and we'll let y be all the values that could come out, meaning in this case 5, 8, and 0 could be what y would equal. Now, we're not going to start working yet with the actual equation. That's for the next unit. But we are going to start looking at the situation, or a way to describe the situation, that when x equals 3, y equals 5. When x equals 6, y equals 8. When x equals negative 2, y equals 0. And so we're going to look at that. So first, let's make a number line for all of our x values, and I'm going to make it in the same color. I'm going to make it in green. And the number line is just the number line. You have 0, 1, 2, 3, 4, 5, 6, 7, 8, on and on and on to infinity. And then on the other side of 0, you have negative 1, 2, 3, 4, negative 5, 6, 7, 8, all the way to negative infinity. We're going to call this the x-axis, which means the number line for the x variable. Then we want a number line for the y variable. And it seems like it might be, I'm going to do something like this, but that isn't as useful as the actual number line, which when we sketch it in the y number line, we're going to have the Cartesian coordinate plane. And if this is 0, what we're going to do is make the y number line intersect with the x number line right in the middle of 0. So now we have a y-axis. So we have a number line for x and we have a number line for y. All we have to do now is decide, are the positive y's up or the positive y's down? And always, 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 the positive y's are up. So this would be 1, 2, 3, 4, 5, 6, 7, all the way up to positive infinity. And then the negative numbers are down. Minus 1, 2, 3, 4, 5, negative 5, 6, 7, 8, all the way down to negative infinity on the y-axis. This is called the Cartesian coordinate plane, or just the coordinate plane. Oh, I-E-S-E-A-N, Cartesian. I may have spelled that wrong. It's named after a mathematician called Descartes, who invented this. So let's look at it. I've got some values, right? I've already put when x equals 3, y equals 5. How could this be useful for us? Well, it turns out we can plot 3 and 5. We could turn 3 and 5 into something called an ordered pair. So we can say, in order, always the x value first and then the y value. Ordered pair, that's what that's called. It's always x first, it's always y second. They're in order. And we put in our value for x. In our first case, if x is 3, and I run it through the equation, 2 plus 3 equals y would be 5. And now I can put this outcome for this equation on my Cartesian plane. So when x is 3, 1, 2, that's here on the x-axis for 3. Y is 5, that's here on the y-axis, positive 5, right? So what I do is I go right in line with the x and right in line with the y. So you imagine if I had a little dotted line and a dotted line, that they would intersect right there. And we call that the point 3, 5. 3, 5 is the address, and that's the point, one point that can be created by this equation. Let's do another one. When x is 6, y is 8. Okay, we can do that. We have a 6 right here, and 8 is 5, 6, 7. I didn't put it on in the first go round, but 8 would be there. So again, we don't tend to draw this dotted line, but I'm drawing it just to make the point. Ha ha ha, point, a pun. We don't tend to draw them in, but they're useful in the beginning just to understand what you're doing. So the place that intersects where 5 is on the x-axis and where 8 is on the y-axis would be right here, and that's the point 5, 8. And that point, excuse me, I said 5, it's really 6, 6, 8. Let me double check I didn't make a mistake here. Yep, 5, 6, and then 5, 6, 7, 8. Yep, that's 8. So that's the point 6, 8. So this equation is going to create this point. And all we care about, again, at this time, I'm just sort of using the language to get you familiar with it, is this is a point 3, 5, this is a point 6, 8, and we have one more point that can be graphed on the line, graphed on the Cartesian plane, and that's -2, x is -2, and y is 0. So if I go to the -2 on x, that's there, and go to 0 on y, and 0 for x and 0 for y are in exactly the same place. So that means I'm going to go in line with the -2, and I'm going to go in line with the 0 right there. That point is called -2, 0. So notice a couple of interesting things just happened. We have 3 points on the graph so far. I referred to this point as being 0 for y and 0 for x. In fact, we call that point the origin. And it's at the point 0 for x and 0 for y. We don't tend to label it with 0. Sometimes your textbook will because it can do it neatly, but for us it tends to make a mess if we get in there putting too many numbers on our graphs. So this is just called the origin, and it's at the point 0, 0. But notice this point. This point also has something very interesting going on. It is on the x-axis. It's different than these points, right? These points are off in space somewhere, but this point is actually on the x-axis. And we would describe it as being on the x-axis. If you were asked to name the location or identify the location of that point, you would say it's on the x-axis. In fact, there's a corresponding point where if x equals 2, what would y equal? 2 plus, if x equals 0, what would y equal? 2 plus 0 equals 2, so y would equal 2. If I plot that point, I'm looking at 0 on the x-axis, which is always at the origin, 0 on the x-axis, and 2 on the y-axis, 1, 2. And where those two lines intersect is right there. This point is labeled, if you were asked to say where does that point live or reside, you would say on the y-axis. And it's on, because it's right on the y-axis, it's right on the x-axis. So how would we describe these 2 points then? Where do these 2 points live? Well, it turns out each square, notice that when I made the Cartesian plane, I sort of created 4 squarish regions. I haven't put the outside over here like a box, but I have a region that's in the upper right-hand corner, a region in the upper left-hand corner, a region in the lower left-hand corner, and the lower right-hand corner. We call each of these a quadrant, and we use the big fat letter Q for quadrant. So Q means quadrant. Okay, and we call this one quadrant 1 using a Roman numeral. So the first quadrant is any point that lives in this upper right-hand corner. So these 2 points are both in quadrant 1. Any point that's over here would be in quadrant 2, and I'm not going to plot any there. We're just talking about labels right now. Any point over here would be quadrant 3, and notice we're just working in a counterclockwise direction. And any point over here would be in quadrant 4, always using Roman numerals to describe the quadrants. And remember, I called these ordered pairs. Because they're in order. The x is always first, the y is always second. X's are always first and the y's are always second. These are called ordered pairs, and they serve as the address for a point, right? So the address, this point's address is 6A, this point's address is 3, 5. Points can also have names, and when we name a point, we often use letters. It doesn't have to be letters, but we do use letters. So this could be called point A, this could be called point B, this could be called point C, and this one I could call point D. I could have called them P, Q, F, J. I could have named them with numbers, but that gets confusing with this. I could have named them with names, Bob and Sally and Ted and Alice, but that'd be crazy. So we tend to just use a capital letter to refer to a point. So let's kind of do a little bit of playing around with this, making sure that we understand completely. So we want to describe points on the Cartesian plane that are located at, we're going to call this point G. This is -3. And this is on the y-axis is at -2. And we have another point F, which is at +2 on the x-axis and -1 on the y-axis. And so we want to give the coordinate and the location for each point. Okay, so let's start with G. G has a coordinate. X is -3. Remember that dotted line. X takes us to -3. And the horizontal dotted line for Y takes us to -2. So that's the XY coordinate for G. And the location for G is in quadrant 1, quadrant 2. G is in quadrant 3. Okay, now let's do the same thing for F. Oh, I didn't give you a letter for that. This is F. So F, the point F, has a coordinate of, well, the X lines up with 2, and the Y lines up with -1, and F is in quadrant 1, 2, 3, quadrant 4. You don't have to put these lines. I do sometimes, I don't sometimes. So in this example, we want to plot some points that are given to us. Excuse me. So A, we're going to plot point K, and its coordinate or address is 1, -1. Then we're going to plot L, and its coordinate or address is -1, 0. Then we're going to plot M, and its coordinate or address is -4, 2. Okay, so first, I know I need to go to -4 on the x-axis. 1, 2, 3, 4, -4. And I know I need to go, my biggest number on the y-axis is 2, so I'll just keep the same intervals or spaces between them. Okay, so K, X is 1, Y is -1, and the place where those would exist together, or the place that those two lines would intersect, is at the coordinate 1, -1. But we don't want this to get super messy, so I'm just going to label that K. I'm not going to put the ordered pair. If I want to know what K is, I can look around the page. There it is, and then I can see exactly what it should be. L, -1 on the x-axis. That's right here. And 0 on the y-axis. We know where that is. And so that's L. And then M is at -4 on the x-axis and up 2 on the y-axis. So in line with 2 and in line with -4 is right here, and I'm going to label that point M. So we're done with that. And last but not least, sometimes the data or the points are given to you in a table and you're asked to graph them. So sometimes you have a table that looks like X or input values and Y or output values. So when X is 2, Y is 3. When X is -4, Y is 1. When X is 0, Y is 0. When X is 1, Y is -6. And so if I wanted to plot these, I could write them as ordered pairs using the same language I just used a moment ago, and I could give them a name. So let's call point A, the first one. When X is 2, Y is 3, so that's 2, 3, written in order, X, Y. B could be -4, 1. C could be 0, 0. And just to make the point that I don't have to work in order, Z could be the point 1, -6. And if I wanted to plot these, and of course I do, so let's see, my X values have to go up to -4 again, -4. And my biggest Y value is -6. So I need 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Notice how my intervals on the y-axis are squished up and my intervals on the x-axis are all kind of spread out. That's always okay as long as all of the y-axis intervals are the same and all of the x-axis intervals are the same. They don't have to be the same as each other, but on each axis they have to be the same. So these are all my x values, these are all my y values, and -6, 1, 2, 3, 4, 5, 6. -6 is here. Okay, so let's plot these. 2, 3, x is 2, y goes up to 3, right in line with 3, right in line with 2. Notice I'm putting values. You have to label them. If you plot the point, you have to label them. And I'm going to give it the name A. B is -4, 1. So I go to -4 on the x-axis and up 1 on the y-axis. And that's point B. C is 0, 0. We know exactly where that is. That's the origin. And Z is 1, -6. So I go to 1 on the x-axis and down to -6 on the y-axis. So let's write -6 over here now. And that's the point Z. And that's it, except for your practicing time. The Cartesian coordinate plane, how it's constructed, and different ways to work with it.